Number 13 was having Maclaurin and then some small changes, the application of differentiation. So part A was saying use Maclaurin theorem to expand that. So start by, we let f of x be that function given to us. Then I need its first derivative, second derivative, and the third derivative because they told us up to the term in x cubed. So if my f of x is natural log of 1 minus 2x, then I'm going to differentiate it. My first derivative is differentiate natural logarithm by saying differentiate this negative 2 over the function there, which I can ably take up to get me negative 2 into 1 minus 2x power negative 1 for easier differentiation. So now I come for my f double prime of x, which will give me lower the power to get me now 2, reduce the power by 1, differentiate the bracket. So you can ably see that now my f double prime of x is going to be minus 4 power negative 2. Then now my f triple prime 8 by 1, shade the bracket, which most people forget. This will be now negative 16 power negative 3. Now evaluate all of them at 0. So if I evaluate everything to 0, I come here. So f of 0 is going to be, when you put in a 0, natural log of 1 is 0. Then I come here, I evaluate f prime of 0. And I put in here 0. I remain with only negative 2. And I evaluate this also, f double prime of 0. And I put in 0, anything I get 1, anything to power 1 power anything is 1, giving me negative 4. Then I put in a 0 there. I'll be getting 1 power negative 3, which is 1, times this, negative 16. But remember, our f of x is f prime f of 0. Substituting, our f of x is our function. F of 0 is 0 plus x into f prime of 0 is negative 2. 1 factorial is 1. X squared. F double prime of 0 is negative 4. Then 2 factorial is 2. Then plus x cubed, this is negative 16, 3 factorial, that is 6. So now, natural log of 1 minus 2x is minus 2x, reducing to minus 2x squared, then this will be negative 8 over 3 x cubed plus other terms. So that was part A. Then when you come to part B, they wanted us to use small changes. So start by saying, let our y be tan of x. Then when we have a small change in y, we shall also have a small change in x. Now from there, remember, if I can compare these two with my tan of 45, my tan of 46. Tan of 46, the special angle there is 45 plus 1. So if I compare those two, that's that my x is 45, then my delta x is 1. All these are degrees. So our interest now is to get now the y and then the delta y. We can get y from here. Our y will be tan x, but our x is what? Is 45, which is 1. So we are missing now the value of what? Delta y. But we all know that delta y over delta x approximates dy dx, implying that now my delta y will be dy dx times delta x. Now from here, I start by getting my dy dx, but from here. Remember my y is tan x, so dy dx will be, negotiate tan, we get a square of sec. But we know that we have our x already, so this will be now sec squared 45, and when you press that on the calculator, your dy dx will be sec squared is 1 over cos squared, which will give us, there we shall be getting our 2 and square, because we shall be having 1 over root 2, but the reciprocal will be root 2 over 2. When you square it, then we'll be getting a 2 there. Then I come to my delta y. Remember, in radians, our delta of x approximates tan of delta of x. That now my delta of x will be tan of delta of x, which was from here was 1 degree. So now my delta of x will be tan of 1, which is 0.01746. Then I come and I get my delta y. My delta y, remember I said it's dy dx times delta x. My dy dx is 2 times 0.01746, which will give me it will give me 0.03492. So it means that now from here, what I wanted was y plus that. So my y plus delta y will be equal to tan 46 degrees. But my y was 1, delta y 0.03492 equals to tan 46. But this is an approximate value. So if I give it to 3 decimal places as the question wanted, it would be 1.03 to 3 decimal places, then I'll round off to get 3.5. This will be the 3 decimal places equaling to tan 46 degrees. So that's how we had to solve that question. But if you want more about using small changes to approximate those angles, still you go to the playlist there, you will see differentiation, then you look for small changes. Okay, let's go to number 14 in there.